So as we have seen so far, we've seen these graphs, right? And then what we can say, just by looking at them, is that they are non-linear, right? And even when we started, we said the ordinary differential equations that we come about when we describe the systems are non-linear. But then there are times where we have to turn them to linear, especially if you are doing a Laplace transform, right? You have to even turn them to linear before you can even operate on them. When we say linear, is that there shouldn't be a case where we have a function. So let's say, so something of this sort. This is actually linear. So that's why we're able to do the linear, what do you call it, Laplace transform on it directly. But if it happens, just if it happens, that you have the equation in a form that is slightly different. So let's say something like this. Instead of seeing this, you end up seeing something like this attached to this one, right? So if it's non-linear, means that in some point or some location within the equation, there are places where you have a product of the function and its derivative. So let's say here of the quantity and its derivative. So let's say x, you have here, you have x times the x cube over the t cube, right? And then here too you have something like, let's say, yeah, even if you have, let's say, what is it, let's see, the the let's see, the x, the t, and in bracket, let's say we have the x, the t, let's say squared, let's say squared minus 2. Whenever you see any of these terms in the ordinary differential equation, then it's non-linear, and as such we cannot do the Laplace transform on it directly, right? But then there are ways of linearizing equations like that, right? So we've seen that they are non-linear like this. So one way is that we use what we call the Taylor series, right? The Taylor series. This helps in linearizing it. So what it does is that, so for the linearization, what it does is, so like we know that this whole graph here is non-linear, right? So it just picks a portion of it. Let's say if it picks a portion, let's say from here to here, right? Or even this one is too much, it's too long. Let's say we pick a portion, like let's see, let's pick here. So clearly, somehow, you see that this side is sort of linear, right? So there are a whole lot of ways of linearizing it. So when you linearize it, then you can do the Laplace transform on it, and then you can get a solution, and then you can say, oh, that's what we're getting. So the equation has become algebraic, and you can see what's happening, right? So that's the linearization, right? Yeah. All right.